Plain Truth. I'm your host, Plain, where each week we try to explore some anomalies, mysteries, and some of the questions that are out there in the world around us. Joining us this week, we have Mark Dansie, who's well known in the alternative or energy research field, and along for the ride, my friend Groundrod. Mark, are you there?
Yes, sir. I'm here in the Philippines at the moment, so I do apologise for any background noises like chickens, roosters, or gunshots.
Oh, that's okay. They come with the territory, right? I mean, when you're in the United States, you have to deal with the same thing, right? No. At least the gunshots, right? Um,
I feel safer here.
I believe you. I believe you. Um, well, first, before we get going, I wanted to, should we call you Mark, or is Darth the name you prefer to go by?
Mark will be fine. Darth,
Mark, okay.
yeah, that'll be
Darth
fine.
is for when you're dealing with all of those people who are trying to promote stuff that doesn't quite work right. So,
That's
uh,
correct.
okay. Well, anyway, why don't you tell us a little bit about yourself? You've been in this field quite a while, and how did that happen? How did you get into all this?
This is. I worked at a university for about 10 years, running a few commercial divisions and working with different people. And I haven't got a degree, which is quite amazing. I was in senior management without a degree. I used to run the publishing company and a few of the commercial arms. I left the uni, played with my ranch or farm, as you call it. I lived in an area where there's a lot of people, alternative lifestylers, hippies, with the solar panels and all the rest. And I developed a real interest in these technologies. And I was a currency trader at the time, freelancing and teaching people currency trader. And how I got into this business is about 7, 8 years ago. My daughter, who was then 13, we're on our summer vacation at the beach, and she must have done a school project or something and was very upset. And she came up to me, and she's a very gentle soul, and was sort of pointing to me and said, "What is your generation going to do about the mess you left us?" And more importantly, regarding environment, inequality of people around the world, the rich and the poor, the environmental mess. And she said, "No, not what your generation's going to do. What are you personally going to do about it?" And that sat me down in my tracks. And within 3 weeks, I'd quit everything and I flew to Texas, and I was installing hydrogen devices for testing in a laboratory in Texas for emissions. And that started my adventure. And from there on, it just sort of got crazy. And I've traveled the world many, many times. Last 18 months, I was in Utah working in a lab, working on these energies. I'm now in the Philippines putting together 2 or 3 final pre-manufacturing for products to help the third world. And it just sort of got crazy. The network just built bigger and bigger and bigger. The more I traveled, the more people I met up with. I just got involved with more and more people, and the field kept expanding. But the funny thing is, it's like it's a big field, but it's also a small field. Everybody knows each other. So my job was to go and find the truth, as simple as that. Go and find out what works, what doesn't work, what is a mythology, what is a benefit, what's worth pursuing, and where can we bring about these changes to answer my daughter's question. And I'm trying to honour that. What she asked me to do is what you personally do to get the environment out of the mess it's in, and also with being able to get people. The thing that impoverishes most poor people in the world, 1.6 billion don't have electricity, and they're relying on big oil for the kerosene to do the lighting, and it's costing them 30% of their income. So anyway, I hand it back to you guys. That's how it started. My daughter put the challenge up, and I'm trying to live up to her expectations.
Well, that's cool. So I guess a simple question would be, in all this time, what kind of stands out in your memories of, like you saw something and said, wow, this is really going to blow the world away?
The TSA. No, I'm only kidding. They steal things out of my suitcase. Uh,
Oh, hey, I could tell you, I've got, particularly my wife has a grudge about Portland Airport. But anyway,
yeah, enough of that. I guess what I was disappointed about was I went and saw lots of devices like magnetic motors, claims of different genres, and none of them worked. Not one, not a scary. So there were some technologies that I was keenly interested in, like self-running motors, generators. The things that stood out to me, and even this week, it's amazing, are the technologies that are coming through that will have an impact. There's two parallel paths here. I want to divide them straight away. Firstly, there are the existing renewable technologies like solar, like wind, like wave, thermoelectric. Those are progressing in the last 8 to 10 years, are going off the Richter scale, off the register. It's just ridiculous. If people want energy independence now, you can put your solar panels on your roof for under $1 a watt if you go and look around and buy them. You can have electric car to charge off them, run your house. Okay, that is a reality in Australia. I'll give you an example. In my home state, 20% of the population now have solar on their roof. 60% have solar hot water. 30% of the rest of electricity is supplied by wind. My niece, she gets a check in the mail from the utility company each month. She's got a roof full of solar. My friend in America, Jim Dunn, he's a great guy. He's got enough solar on his house now, or is about to put some more on, where he can run his whole house and charge his Chevy Volt or his EV up. So people, those things are just moving so fast. And when you see the rate of installation, it's changing the whole dynamic of energy, such as grid energy. So you might call that conventional science, but that is a parallel field that I work in. The big breakthrough, and they have got it in the lab, the thing that's going to impact you and me and everybody else in the next 3 or 5 years is storage and battery technology. So you will have the electric car. There's a mental barrier that if the car can't drive 500 miles, oh, we're scared the battery's going to run out and blah, blah, blah. Anyway, within 2 or 3 years, you're going to be able to drive that 1,000 miles, at least 500, maybe in 5 years, 1,000 miles on a single charge. And the other thing that storage will do, it will get rid of the grid. The only thing that's stopping the grid disappearing now is the cost of storage or battery storage for a household or a local microgrid is very, very expensive still per kilowatt hour generated. So you're going to see a big impact. And that storage, there's 30 or 40 companies I know of America working on it. They've got brilliant solutions. And a lot of it's still in the lab. Some's in pre-manufacturing prototyping. Some is actually getting geared up for manufacture. That will have a big impact. So I just wanted to divide that off, but I'll get back to your other question. I'll take a breath. The exotic technologies, I'll get back to that. I just want to point that out, that there is a revolution that's happening right now, and you can be part of it.
I wanted to, this is Ground Rod here, Mark. I wanted to ask you about zinc air and nickel iron battery technologies. In rural Montana here alone, we've got in 2 different parts of the state little companies that have taken off and are producing products. One's around the zinc air concept and the other nickel irons. I was curious about those two.
Absolutely unbelievable. In fact, the Tesla, Elon Musk, and also the Israeli company, they've already put the patents on using a combination of, zinc air, lithium air, a whole lot of other these technologies to use with traditional recharging batteries with their cars, and you'll get 1,000-kilometre range. I can actually build a magnesium air battery now, but it's too costly per operating cost, but I can build one and drive a vehicle to New York and back without stopping, from LA. I can, do 10,000 miles without stopping if I wanted to. But the cost of the fuel, the magnesium, is expensive. But then it comes to economy of scales, something that I'm deeply close to me in the project I'm working on. We're looking at these third world countries, and we're also looking at Western countries. Like, we're working on one of those technologies. I can't say exactly which one at the moment because of we're right in the middle of some IP and that. But we're applying similar technology and using water and using a metal and stuff like that, and using apparatuses that breathe air, like they're using the cathode. And suddenly, rather than a family having to spend $1 a week for the kerosene to light up their hut, We can light it up with this technology. It'll cost them 5 cents a week. Not only that, they can charge their cell phone from it as well. And from a consumer point of view, we'll be releasing a pile of flashlights, lanterns, radios, whatever you like, and you'll just use a piece of this stick of this metal, about the size of a AA battery or 2 AA batteries, at a cost of what you'd pay for, an alkaline AA battery, and it'll last for 100 times. It will last for about 100x the actual life of a battery. So one of our little sticks or rods, as you're talking about, whether it's lithium air, zinc air, nickel, that technology will mean that a consumer can go into a shop, buy a radio flashlight. It will last for years. It will never lose charge on its battery. If you pour water in 20 years' time, it will run. It's going to make a huge difference. So those technologies are a real breakthrough, and they're going to have an impact on the Western world, and they're going to have an impact on the third world in a very large way. And you're right, it's there now. Companies are being formed. We're forming one over here now, putting a consortium of manufacturers, distributors together to release a whole lot of products, both through the NGOs in the third world and also in the first world, to put these technologies into the Walmarts, so you can go and buy, hey, I can buy this light, just add water, and it'll run for 300-400 hours, not 3 or 4 hours, and then every year or so I have to replace a small metal rod that costs me the cost of a normal battery now. So I hope that answers your question. It's big. It's a big breakthrough.
Sounds good. Thank you.
That's pretty important. So how long before you think this starts to really appear in the real world?
Next year. You'll see it in a big way, actually. Not only our company, but dozens of other companies. You'll see applications coming from all directions. And it's not over unity. It's a bit like solar, wind. It's just conventional science being used for high-end military work now, and other research is being applied in a multiple of ways, and it will have an impact. I mean, our product will be pushed a lot. People think, oh, you're running on water. No, water's not really doing it. We are consuming something. But what we're consuming costs half a cent, in dollar value, equivalent to a AA battery. But the resource we're using, there's trillions and trillions and trillions of tons of it in the ocean. So, we've virtually got an inexhaustible, and we can actually reprocess it and reverse the role. But I guess what you're really interested in is what exotic technologies are working out there. You hear a lot about
the ECAT.
The ECAT. Well, LNER is a really interesting field. Okay, there's a few little charlatans and little con men out there trying to profit out of things, and I won't mention name, but I can think of an Italian guy. But there is some real research. Just this last, or not in the last week, I did a story on it the last week. Mitsubishi and Toyota have both repeated this, conducted and repeated this experiment, where they actually have shown transmutation does take place. This is real science, real scientists. You've got probably 100 other research projects around the world, from little guys in their garage to people like Beryllium and Blacklight Power, been working on this for 2 decades. They're all seeing an anomaly, but they don't understand it. And nobody's been able to engineer it yet into a process where they can control it or get any useful power off of it. So I think you're a few years away before you see that LNER become mainstream. However, I would like to be proved wrong, and somebody might make a breakthrough in the next couple of years. There is some other small, what I call similar research with the thorium area. And I think thorium is exciting because they can build safely micro-reactors now that could power your house or your neighbourhood or whatever for 30 years. And there are a lot of companies are working on that in the States. But more importantly, we've had Fukushima. We've got this huge nuclear infrastructure that is really screwed around the world. It's dangerous. Fukushima could happen anywhere at any time. The thorium reactors they've got, rather than like with conventional nuclear where you're fighting to control the reaction, with the thorium, you're fighting to make the reaction happen. If anything goes wrong, it just shuts down. It can't release harmful gases to the atmosphere. It can't melt down. It just shuts down. And the cool thing is the products, the materials that to the waste product are minimal, like a fraction of the volume, and they're pretty safe in a few decades or a couple of hundred years. You don't have to wait 32,000 years. And the Chinese have got 6,000 people working on this. One company's got 150 PhDs, 700 scientists. They're going to build the reactors. They're going to power the country with it. India has just built their first 300 megawatt one. They're going to be running on thorium 30% of the time. You've got Norway, Finland, dozens of other countries around the world are pushing. And I'm very supportive of this. It might be radioactive, but it's not. It's very, very safe, sensible use of a resource. And the coolest thing is the materials can't be used for nuclear proliferation of weapons, which is the reason why the other one moved ahead the last 5 decades is, we can build nuclear bombs out of this. Whereas this one, you build a reactor or have a home reactor or a neighborhood reactor, it's safe.
So, Mark, when we read in the papers about how India or Vietnam or whoever want to build a bunch of nuclear reactors, and they're in negotiations with different countries like Japan, these are all the traditional conventional ones, right?
Not with India now. India is on a path of thorium. They've just built their first one, and they're intending to power 30% of their grid with thorium reactors within 20 years. So they're shifting. China especially is shifting big time. They're doing more research and spending more resources than anybody else in the world. So I think once or two countries do it, like India, the rest of the countries will be like sheep and they'll follow and they'll do this because it makes sense. The ones that have got an interest in keeping the existing nuclear technology are the huge companies like General Electric and all that, because they've got so much money invested and they can charge through the roof for the expertise, because it takes a lot more expertise to keep a traditional nuclear reactor. It's a lot more dangerous, it's lots more weapon sensitive, whereas the other one, it's pretty benign. It's no worse than a coal-fired power plant. And just before I get off this, here's some really cool news. We've had peak oil, you've read about that, or it's happening soon, but we've got peak coal at the moment. And in your country, in one state, Pennsylvania, they're shutting down a third of the coal-fired power stations now. In Australia, they're never ever going to build another coal-fired power station ever again. They don't need to because of the impact of solar and wind. And then in another decade or so, these thorium reactors will come along. And in China, they're going to cap the amount of coal being imported, and they've now banned building new coal power-fired stations in certain regions in the country. So while we're waiting for the over-unity of the miracle fix, the impact of solar, wind, and a whole lot of other renewable energy technologies and the pickup rate is already having a massive impact. In Australia, 10 years ago, the coal-fired power stations couldn't keep up with demand. They were having brownouts, shutting down on a hot day, everybody's air conditioners on. Now, they're running at 60% capacity. In fact, some of the plants are shutting down, and there's no plans to build. In fact, a $7 billion coal mine planned to supply China and Australia just got canned, wiped off the board. So what I'm excited about is a combination, a whole tirade of these technologies are coming forward, and it's more about good government policy and how to get the people involved than it is about, is the technology there or not?
Okay, a question. A lot of people are going to be of the view that the coal question was more political. At least, let's say, Americans listening might say, well, isn't this more just geopolitics? They want to develop fracking and natural gas. And in other words, it's not necessarily that coal is running out. It's that's not what the powers that be want to promote. Have you got any thoughts on that? I mean, the fracking revolution and all that kind of stuff?
Well, it's really interesting you bring that up. If you go to the financial institutions now and the Wall Street and investors, coal being and traditional utility companies, they're on the blacklist. You're not going to find much money there. Development banks, World Development Banks or European Development Bank will not lend money for coal anymore. They will lend money for renewables. Okay, so there's been a huge shift in the financial structure in the banks on what they will lend on and what they won't. There's also coal's gone to high risk, wind and solar's gone to low risk. I'm not talking about investing in cylinder or manufacturers. I'm talking about investment in building plants. Now, your country, specifically America, China, in Japan, for instance, where Fukushima is, they're now putting 140 windmills that are going to replace that power plant, floating them off to the ocean there. I'm not saying that's the best solution, but they're doing that. The number of individuals in Japan picking up solar for their house is massive. But in America and Australia and Germany, look at Germany, their energy independence on solar and wind now, it's huge uptake. England, I could go around the world. Australia, my home state, in 10 years, from 0 to 30% wind power, from 0 to 20% of all households PV powered. But in America, you needed energy independence. So figured out you're getting grossly unpopular, running around the country, invading other countries to get their energy resource. I mean, let's face it, you can't do another Iraq. If you invade Iran, you're going to be all by yourself. Nobody's going to back you. Nobody's game to back you. It's not because Iran's a bad country, but the Chinese, the Russians, and the locals, they'll take care of it. It's a regional politics thing. And they want to make sure that resource is available for them. After all, it's their neighbour. So America took this path of, they got to get rid of the polluting coal-fired, but fracking was, you've got 450,000 gas wells now, I believe. Fracking and developing the oil fields, like in the Gulf drilling now, after the BP fiasco, Gulf drilling has increased 40% now in the last year. So your company's answer to energy independence was fracking, the gas. And it's not a bad thing, the gas. It's just that fracking really screws up the environment. In many parts of Australia, fracking's banned because it does affect the water, the groundwater. It has all these other really bad effects on the environment. But that was your country's path to energy independence. Drill more, frack more, coal sort of on the way out. And what you'll see in the future is what they're often doing is with wind farms, like in Oklahoma, the guys putting all the wind farms there, he bought up land that's sitting on gas. So the authorities now saying, hey, our grids can't handle all this solar and wind because of the fluctuations. You've got to put storage in. So what they're putting is cogeneration. So that a lot of the fracking will go to gas-fired, smaller gas-fired turbines that will work in conjunction with solar and wind. I'm not forming an opinion on that. It's just the path your country's gone, whereas the rest of the world is embracing renewables at a much greater rate than America is.
Well, what about, we see essentially what are argued to be gas wars, the whole Middle East, the fights against Russia over everything every day of the week. And they largely seem to be based on control of gas. So where does that stand? I mean, superficially, it would look to me like there's a big push for natural gas around the world.
There is. Countries like Australia got a 2,000-year supply. One of our biggest export industries is shipping gas in large ships up to Asia. There is a bit of stuff, I'm not an expert in this field by a long shot, with Russia and supplying Eastern Europe with gas. There's a few little local skirmishes. But here's an interesting thing. You talk about the Middle East. OPEC now, you've got the problem that Saudi Arabia, they've had, always a controlled supply and they controlled the price. They can't sell the stuff now, oil. Their actual supply or demand for their oil is dropping. It's actually dropping. It's decreasing. So they're reaching their head. What in the hell are they going to do? How are they going to protect their little backyard? That's partly because America's becoming less dependent on their oil, but people are moving to new technologies. To me, the EV, or electric vehicle, you're not going to see a big impact, but in 5 years, you're going to see a massive impact. And that's where it's really got to, all this value they've got now, the oil companies and the Russians, for transport supply of energy, it's just going to start to fall over, just like the coal is now, is falling over supplying the grid. I think gas will have a long-term role. and gas will always become a political issue in some regions. But you're going to have this situation where the demand's not there. It's like in Australia with the grid, you know, hey, we don't need coal anymore, or they will go to gas-fired rather than coal. But eventually, I think by 2040, it'll be 100% renewables. The Philippines, I'll give you another example. The Philippines, there's 96 million people on a few islands. It's pretty populated. They're going to be 100% renewable energy within 10 years. They're well on their way now for their grid. For transport...
How are they doing that?
They're blessed. They got a lot of... they're on hot rocks here. I'm 30 kilometres, 20 miles from an active volcano. They're doing mainly thermal. They're also putting wind on. They've got a lot of coastline. They've got 7,000 islands. So they're doing wind, thermal, not so much solar. That's how they're doing it. But they've already been on a path for that for many years. Many other countries are well on their way, including Japan now, and Germany, they're probably ahead in Europe, are well on their way for this self-sufficiency. But what's really cool here, I read about, hey, in America we've got the Tesla, which is great. The Tesla was the biggest selling car of all motor vehicles in Norway last month. That's a pretty cool thing. But here, I'm sitting here, okay, we got the grid sorted out. What are we going to do about all this pollution? I mean, here there's no emissions laws. You know, the jeepneys, the little taxis they use, which is a 150cc motorcycle with a sidecar, and there's, I forget how many of them, there's 3 million of them in the country. It's just crazy, polluting with two-stroke motors and that. What are they going to do? So there's one company here, they're going to build 150,000 of these things. Electric taxis, not 5,000, not 500, 100, no, sorry, I think it's 50,000. I have to go and check my own statistics. They're going to build 50,000 of these, or no, 150,000, sorry, I just checked. That's cool. It's not like in New York they put 6 taxis, hey, we're doing electric taxi trial. Here they're going, we'll build them, they'll use them. So there's 150,000 electric vehicles going in this country in the next 3 years just for public transport. And I'm seeing other technologies now that are just blowing me away, like public transport in Utah, Salt Lake City, and also in Korea. They have an electric bus. What's the problem with electric bus? You've got to carry huge batteries to get you around. So what they've done in Utah now with the university at the campus, and what they've done in Korea for their airport run, they have buses. They're using Tesla technology that pick up when they stop for passengers, or in Korea, they've actually got a wire running down the road. As they're driving along, or they stop, their batteries are getting recharged by radio inductance, if you like. They can get 95% efficiency. So you can drive your bus around all day long, and you're not relying on the batteries in the bus. They'll be just as charged when you finish the day as you started. So all of these wonderful technologies are just sitting there now. It's just a matter of governments adopting them. And if you want to ask me a really good question, be asking, well, why is America going this way? Why is the Philippines going that way? Why is Australia achieving this? That's a good question, because it's all about politics and control.
Well, that begs the question then. Who's trying to control whom? And well, let's step back a second and say, okay, the Philippines has all these oceans to work with and all these hot rocks. Okay, well, let's say New Zealand and Japan have plenty of volcanoes and oceans. What are they doing?
New Zealand is, I believe, and somebody will correct me, I think they're already 85% hydro, and they're putting in some big wind farms. They're already 85%. There's a state in Australia called Tasmania. They're pushing 90% already renewable energy. So New Zealand's already down that track, have been for years. I don't know the figures off the top of my head, but I'd be safe to say they're over 70% heading towards 100% renewable. But I just want to get back to a very basic principle, what I wanted to get across on this program. We're all about having energy independence, okay? If we got energy independence, we're not dependent on corporations, governments, or anybody. So people who've got their own little solar place now, like my niece, she's got all the power she needs. If she buys an electric car, she can run a car. She's not beholden to anybody. Now, here's the big difference. And this gets back to the 2008 economic crisis. And I'm going to give you a very quick example. What did America do when the meltdown came? They gave the banks a few dollars of taxpayers' money. Would you all agree with that?
At least a few.
Okay, they gave a few
Oh yeah.
billion. Okay, right. They gave them the money. Did those banks then go and help the people with houses, with mortgages behind and that? I'm asking you that question. Did they go and help the little guy?
No, because they're trying to bring in feudalism.
Okay, right, exactly. In Australia, and I'm using Australia because I know about this one, they gave the money to the people so they could pay the banks. And guess what? The banks got their money and the people saved their homes. Doesn't that make sense?
Yes, of course.
They also regulated the banks so they couldn't get in this mess. Okay. Now, here's the energy thing. What did your dumbass American government, well, they won't let me in, what did your wonderful American government do with their energy? They went to the corporations. So what they did was they gave the big money for manufacturing like Cylinder and blah, 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 blah. Okay? And that fell over. You wasted a few billion. The other thing they did, they gave the money to the power companies. So the power companies could build big wind farms, big solar farms, and still control the people and the grid. Would you agree with that? That's a fair assessment of what they basically did. They gave all the taxpayers' money to the big energy companies and also to try and boost manufacturing. Is that a fair assessment?
Yep.
Yes.
Okay. As a result, you've got some mega big solar farms, some big wind farms. That's good. Your manufacturing, you fell off the cliff. Well, they all fell over. You know, go to China, buy things. What they did in Australia, and I'm using Australia, many other countries did this, they gave the money to the people. They figured out, well, if we give the money to the people to buy their solar systems, and they were subsidising up to 80% of the cost, they will create a competitive environment so the people, the manufacturers, the installers, the equipment suppliers like the inverters will get pretty competitive. So they actually gave the money to the people, empowered the people to get their energy independence. Now, they didn't give it to the grid. They didn't give it to anybody else. They gave it to the people. What happened was the installers' jobs outnumbered manufacturing jobs 20 to 1. So they trained this incredible big workforce, created unemployment in Australia never went above 5.5%, even during the economic crisis. There's all these, 100,000 solar installers suddenly putting all these panels in. So they got the people to own the generation. And I remember reading an article, this magazine I corrected, and they said, oh, wow, Australia, the biggest solar farm is 10 megawatts. And said, ours is, 500 megawatts, in a pissing competition. I said, all right, let's look at the real penetration. How many people have got solar on their households, on their roof? And I said 1 million in Australia in a 20 million population. 1 million households out of 20 million people. That's 20% of the population. What have you got in America? Probably less than one in 100 still. So it's about the politics. You have to empower the people. Germany empowered the people, many other nations. You've got to get away from this corporate mentality of propping up the corporations to give control of the country. I drive in America, in Salt Lake City. I love America, safe place, cool people. But I drive along the road and I look at where I'm going to eat. All I see is franchise, 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 franchise. I see a Wendy's. I see a cheesecake factory. I see a McDonald's. I come here to my local province. I see 2 franchises and I see 500 small little restaurants, family owned. Can you see where the politics has gone wrong with the energy equation?
Oh, absolutely. America's, if not fallen, it's kind of in the hands of the corporate oligarchs nowadays. And this is the problem. Absolutely. It's a political problem, not a technical problem or a technological problem. And as you're pointing out, it's not simply in one area. It's really across the board. I mean, it's every kind of shopping. I mean, even a barber. There are probably now more franchises and chains than real normal barbers.
You're right. But you go to Asia and many other countries. I have never seen a franchise barber shop here yet. I go to Taiwan, which is a great country to go and visit, I love their bullet train. I sit at 300 or 290 kilometres an hour on their bullet train. I go there. It's just small businesses everywhere, the barber shop, the restaurants, and that. So I think capitalism's gone too far, and I think the most damaging point I was leading up to is the people have lost control of your government. They really have. The corporations for many decades have been building up and control your government. In some countries, they don't allow lobbyists to see key ministers responsible for a portfolio. You're seeing political campaigns. Who's paying for them and what's the payback? Some countries now, there are no political donations allowed. All the candidates get the same amount of money. And I just want to, but it is changing in other countries, and I don't know how to change it in the US. I really don't. I mean, last time I was there, I'd done nothing wrong, and they said, "Oh, we don't like you coming back so often." So I'm there, all right, so I have to go to a lot of effort to get more visas. But I just want to read you a brief statement, and this is groundbreaking of what's happening throughout the rest of the world in other countries, and hopefully the American government will take notice of this, because to me, it's a statement from a politician. It's just words. I'm just trying to find it now. It shouldn't take long. I'm just about there, and it was here it is. This is in London, right? And this blew me away. This absolutely blew me away, and a whole lot of other people, which leads up to another topic we can talk about, the free energy community. But this is from the UK's Energy, Greg Barker, Climate Change Minister. Okay, I want to read this to you. It's very, very brief. I want to unleash a completely new model of competition and enterprise. I want to encourage a vast new army of disruptive, I underline that word, disruptive, new energy players to challenge the big six. Big six being the utility companies here. From individual consumers to community groups, entrepreneurs, SMEs, and FTSE giants, I want them all to consider generating their own energy at real scale, as well as starting to sell their excess energy on a commercial basis. A decentralised power to the people energy revolution. Not just a few exemplars, but tens of thousands of them. The big six needs to become 60,000. The government needs to do more. Cut the red tape, eradicate overcomplicated policy to drive further growth of the green economy. We must look to far more integrate our new policies that help families produce their own renewable electricity with our new incentives to help families generate renewable heat and make sure that hand in glove with a range of new technologies. Is that a good message? Can you see what the rest of the world is doing and what the Americans failing to do? Does that make, I'll throw it back to you guys.
Oh, it makes perfect sense. I mean, I'm skeptical. That's Britain. I find it hard to believe that Britain is kind of like the mothership of the the world global takeover. New York and London seem so tightly connected. It's hard for me to believe that it could change in Britain, but maybe it is, and that's a good thing.
It is changing. The grids, there's an energy conference in Australia 2 weeks ago. The big utilities, the smart ones, have realised the grid's screwed. Traditional energy generation's gone. They're out of business. The smart ones, you mentioned New Zealand, there's a company there now, a major grid provider. They're now going around leasing, very inexpensively, leasing storage and generation, like solar and the batteries, into individual households. They are really, really, really changing. There's a huge paradigm shift. The good news is you're going to see a massive pickup through some incentives that are changing in America for the individual to achieve energy independence. But I've got off the track of what this program's about today, I think. I just wanted to let you know that a lot of good things are actually happening. America, often your media and the people are a little bit blind what's happening to the rest of the world, and it becomes very insular, and you're not sure what's happening. Whereas, I mentioned the Philippines, New Zealand, Germany, now Britain, and many other countries, and Japan, what they're actually doing is huge, and especially China. China is just going ballistic on renewables. They have to, because if you've been over there lately, you'd choke to death. So I think this will filter through, because the US will miss out within the next 2 or 3 decades. If they're not a clean energy provider, they're going to have they're going to have trade embargoes and everything else put on them, and also they're going to be paying through the nose, because the resources that are left, like coal, oil, and all that, are going to go up in price as they become shorter in demand. They're going up in price, whereas already solar is grid parity, wind is grid parity. And as soon as we get this energy storage devices in the market, the grid is gone. The grid, as you know, is gone, and transport will change dramatically. You won't see 5,000 Teslas being sold a month, or electric cars, 20,000 a month. You actually see 1 million cars a month being sold, and within a generation we'll be shifting to electric or possibly fuel cell, hydrogen fuel cell technology. So you want to ask me some questions on the exotic stuff. I got away from that first question. What have I seen that excites me? You fire the questions. I'll keep the answers a bit shorter.
Well, I suppose it was, the question came out of what's the, kind of interesting things you've seen. So what's perhaps the most, I don't know if you want to say exotic thing you've seen, but what have you had your eyes on for a long time? We just had this global breakthrough conference a couple weeks ago.
Well,
and
yeah, the global
was there anything there? What
no,
did you see?
No, nothing can be demonstrated there. I was at the first one in Holland. I couldn't make this one. They want me at the next one. Nothing could be there demonstrated. And unfortunately, and this is what makes me hugely unpopular amongst a lot of the free energy people, the technologies they've been pursuing are going nowhere and can't work. Cell technology, there's a lot of inside stuff people don't realise. It's not going to happen, okay? So why flog a dead horse? I saw one plant in Thailand, they spent $5 million on it, couldn't get anywhere. The PAP engine technology, okay? Well, you got John Rayner in court for ripping off $2 million off people or whatever he did. Bob Rayner's never achieved over unity with that. But what people don't know, there was another lab that spent $10 million or more, maybe $14 million, so I don't know exact figures, using top scientists, and they still haven't got anything. So there's a lot of technologies I think people got to get let go of, because they're not really, the data isn't there to protect them, to support it. And, Stan Myers, when you really do the research into that, which I did, I met people who busted in first hand, actual real people who stood there and caught him out cheating. So let it all go. Let a lot of these technologies go. What I found was, on my investigation, flying around the world, and there's another 20 people like me doing this at various levels and degrees. I've known people spend millions. I spent low hundreds of thousands. I know people spent millions traveling the world testing these technologies. And what's really, really bad is you get the yield and all that. They're bringing all the media attention, they're bringing all the attention, and they've got nothing. And they just disappoint people over and over again. So you've got to let those ones go. What you've got to do is embrace the good ones. And there are some good ones out there. LNER, you mentioned before, is a field very much worthwhile pursuing, because it's not just nickel and hydrogen. I know of a project, in fact, I'm involved in one now. They got nuclear scientists, they got a good lab. They're working on something, I'd call it LNER, they probably wouldn't, but it is real breakthrough stuff. These are the ones that are going to move ahead. Materials technology really excite me. There are few labs, I was involved in one, but there's a few labs out there developing materials that when they're created, they'll continually produce electricity or very efficiently extract electricity from the environment. And, thorium, those sorts of things, a bit more traditional, they excite me. As far as last year I spent, or somebody else spent, I ran the experiments, we spent 200,000 in labs testing hydrogen, HHO injection, water injection, alcohol injection into diesels in the best labs in your country and also Australia. And we dispelled a few myths, but we mapped out what the science really is and what the benefits are. So to me, a lot of these, is it worthwhile experimenting still magnetic motors? Yes, I've got 3 or 4 inventors I talk to several times a week, all working on trying to crack the magnetic motor. Will they ever succeed? I don't know. But what we've got to do is stop promoting the ones that have been already, proven not to work. We've got to let go of them. And don't just look at the hype that comes out of like free energy news. One side of the story is reported there. What they don't tell you is all the other valuations, scientists, data and all that. If a technology is dead, bury it, because it's just wasting resources, building up people's hopes. And exactly, and you lead up to GBM, they asked me 2 years ago, what have we got? And I said, I can show you a couple of tricks. I can show you material that will, continuously produce energy. It's a long way from being commercially viable, but there are things there. But I said, you've got nothing. You've got a whole lot of hype. And the other thing you've got to watch out for, you want to deal with energy, you want to deal with breakthrough energy, you guys wouldn't know what free energy was if you fell over it. I said, you got all these people, Moray King, very dear friend of mine, keeps telling the same story for 20 years at these conferences. You get these same speakers all saying suppression. There is no suppression. That might have been in the past, but not anymore. In fact, corporations, governments are supporting a lot of these exotic programs. Money's there. I've seen in the last year millions being invested in a whole lot of exotic technology experiments in America, in Asia, in the USA, in Europe. So the suppression, you've got to stop talking about that. You've got to bury the technologies that are gone. Don't go on mythology, don't go on folklore, go on data. And my unfortunate experience was I was bright-eyed and bushy-tailed 8 years ago thinking, wow, all this stuff works. Then I travelled the world, met up with other people doing the same. And, magnetic motors, 30 of them. When I've been to Africa that many times, the US, Europe, Asia, visited these things, 9 times out of 10, it's a measurement error. And if they can't self-loop, you got nothing. So I think there's got to be a shift. Get behind the new ones, let go of the old ones. And I've got a list here of 100 technologies that people are purporting to be real or this and that. They're not. They're just bullshit. And normally got a scam artist behind them. Move over to the ones, exciting ones. The materials technology, there is some very exciting stuff still happening. Sorry, this is supposed to be a conversation. I'm doing all the talking, so you guys better weigh in.
No, it's great, Mark. I wanted to ask you about Kepi Motors out of Brazil. I've been working at a lumber mill here locally, one of the few in the Pacific Northwest that's still hiring, employing people and cranking out lumber, and it's just amazing. Some 500 motors in the place. They need a small substation to keep that place running. Motor technology interests me, and I was just wondering if you could comment on that company in Brazil and maybe some new motor technology that could be important for future industry.
Well, America's leading the way, and this is a really good little story, actually. There's a company out of America. You can get all this stuff off our website. It's revolution-green.com. And we've got another one called Breakthrough Energy News. My good wife puts together every day. She finds all the good technologies. But there's a new electric motor, and it's based on a printed circuit board using the same technology. They've got it's a fifth of the weight and size of existing motor, but you got this, if you like, the copper and that printed on like they're using for printed circuit board technology, really, really small, but you can get the magnets closer, and they're 95% efficient. And there's this company in America called, you might want to look this up on the website. This is a really cool company where America really does some good stuff. Their electric motor, so cheap to manufacture, and they're already building them up to 10,000 horsepower. So for your lumber mill, they can use this technology. It's cheap, it's light, and it's called a Core Motion Inc., right? You look up Core Motion Inc., and they're building weed whackers, lawnmowers, and everything using this technology. And the actual website that you probably want to go to, this is the retail arm. Popular Mechanics has covered this and all that. Is Core, C-O-R-E, outdoor power products. And you'll see the picture of the most simplest motor you've ever seen in your life. It looks like a printed circuit board, magnet one side, and that's it. And so cheap to manufacture, much more efficient than a KEPI. Now look at the KEPI. The KEPI is old technology out of the 80s. The guys haven't got a clue what they're doing. There's actually, the original motor was a fire hazard. And I look at it, this thing here cost a few cents to make, or maybe a couple of bucks. The KEPI motor is using old technology windings. This motor here, right, what their fame is for this motor is a new electric motor that is ironless and wireless. So there's no wire windings, there's no iron in it. All you got is a printed circuit board and a magnet. That is exciting. And it's over 95% efficient. And it's that simple and light. Like I used to do a lot of weed whacking in Australia because of where I lived. We had to do 10 hours a week trying to start those bloody little 2-stroke motors and 4 strokes and noise and all that.
Yeah, I'll be doing that tomorrow.
Yeah, this thing is the size of a fraction of the size of a normal motor. It's about 3 or 4 inches across and half an inch thick. So there's no weight to it, but it's incredibly powerful. The torque and the performance to weight is many-fold any other motor technology that's ever come. And I'm thinking, wow. And they've got circuit boards here and magnets. We're able to drive a mud pup at 1,000 horsepower and 1,200 foot-pound torque. So they're going to apply this technology right across electric motor field. And it's not new. There's been this technology around for years, but they took 5 years to take it out of the 60s and 70s where it was a novelty into a full-blown commercial product range. And I'm really excited by it. So it's core technologies. And here's the other thing. I'm living in the Philippines. I bought my fan. We got a lot of them here. I'll tell you, it's so hot. And I paid $18 for it, okay, the whole bloody thing. If I had this motor on it, it probably only cost $15. A KEPI fan costs $300 for the kit. Now, it's going to take me about 70,000 years to recover my savings on electricity here. I never will. I'm better off actually buying a fan and a solar panel. And then I've got free power to power that thing. A KEPI motor is not over unity, okay? It can't be. I've had a good physicist friend and scientist, electrical engineer go over it. In fact, probably when I talk about things, I'm a dumbass, but I've got some very smart friends who are electrical engineers, who are scientists, who are physicists, mechanical engineers, and they evaluate the stuff, give me the data, and, you know, they put some pretty convincing arguments. And what's really sad is a lot of those arguments are sent to Sterling by me and other people, and we show them, well, here's the truth, and this is why their data doesn't hold up, but it still gets promoted. And so the KEPI motor is a no-go. However, the core NET motor technology absolutely is. And what's really cool, the home experimenter or the people with 3D printers and the new 3D printers can do circuit boards. You can sit there and build your own electric motors in minutes. I think this is cool. So you get me excited over electric motors. This is one of the brilliant technologies out of the US. Next question.
What about the Bedini motor? Any thoughts on that?
Yeah, look, Bedini is one of those ones that need to be buried, okay? There's a thing called the battery effect, okay? I'm serious about this. I have seen, there's one over here, 2 or 3 here in the Philippines. I flew to Africa to evaluate one that Sterling put me on. I took a physicist with a suitcase full of instruments, and I went to this place, and I put this in the, not the magnetic motor field, but the magnetic self-loop type motor generator. I'm going to split the two up now. There's magnetic motors, and then there's the motor generator. I'll put the Bedini in the motor generator. I remember this company. I went along, and they sort of said, you know, you're going to find out what we need to know. By the way, we can have you detained. Great way to start. Their inventor, who we figured out who he'd ripped off and copied, didn't take long. He didn't want us to test it when he saw the instruments because we would have busted him. And this company was actually very honest. The people were very honest people, and they wanted the truth, but then it came with a threat, and we weren't allowed to test it. But in the end, I said, I'll tell you what's going to happen here, boys. I've seen this before over and over and over and over again. When you're using back-pulsed or EMF taken back to the battery, you're getting what they call the battery effect. If you try to close loop this, which you should be able to do when you're 10x as you claim, or you use capacitors, it won't work. All you're seeing is what they're doing with the battery. And what they're doing with the battery is by putting this huge back pulse, they're either desulfating the battery and making it more advanced, or they're changing the architecture. They're creating artificial surface or short-lived surface charges on the surface, or they're actually pitting the actual plates and creating a more efficient battery for a short time. And said, what will happen is, said, I'm looking around your factory and your workshop now, you haven't got one battery that you can't start this experiment without putting it on a conventional charger. You're destroying your batteries. And I give your batteries a few weeks at the most. A month later, they come back and said, you're dead right. Our batteries only last a month, brand new batteries. So getting back to Bedini, he's got the same thing. And what he's seeing is the battery effect. Ask him to run it just on a cap, closed looper, or run itself without a battery, and it will not work. So if they can't close loop it without a battery, they haven't got anything. And you can put Magna Coaster in that one. He was a classic. He used to show his videos, and we'd calculate that system and that load will run for 40 minutes. His video would go for 37 minutes. Okay? The worst one I saw in Africa, and that was a magnetic motor generator, was a guy had already taken 300,000. He had TUV's leading engineer telling us it's true. So I flew a crew in from America and Australia. We had a look at it, similar technology to Bedini. And we found the hidden wire. My Australian engineer friend electrocuted himself when he found the hidden wire. And that was it. This guy, you know, the threat of having a gun pointed in his head, the way they do business in South Africa, was he confessed everything. So a lot of these, anything in the past, I'm not saying the future, I've got some very good friends. Hello, Chuck, I should give him a hello. Some very good friends in Iceland, in America, in Australia. They're working on magnetic motors now. Will one of them break it? Perhaps. At this stage, I don't know. But all the ones in the past, such as Bettini, Magna Coaster, look at Perendev. He's in jail, you know, as a con. They're all cons, and they don't work. And they are relying on batteries. If they're relying on a battery, then it is not over unity. It's what we call the battery effect. I'm sorry, a lot of people hate hearing this, but it's the truth. And nobody can produce data, evidence, third party, or demonstrate anything at this stage with magnetic motors, self-running motor generators, or self-running HHO devices that are supposed to generate electricity and they make the gas, that stand up to any level of scrutiny. And if you saw the tricks they used, you'd be shocked. With the HHO ones, the so-called self-running gensets, the dumbasses, they just introduce alcohol into the system, like water. The really smart ones, they might drop an aluminium plate so you can't see it, and it will react with the KOH and produce hydrogen gas. You know, you're cheating because you're consuming the aluminium. Or some people even coat certain components with hydrocarbons. Every trick you can imagine they use to try and fool people. And with the magnetic motors, I've seen just about everything. I really mean literally everything of the tricks they use to try and fool people. And they do. They're just scam artists. Should the research continue? Yes. Should we support them? Yes. Are there some real efforts happening? Yes. But is there anything in the past you want to mention? I can give you the answers. And unfortunately, in every instance I know of, or other people like myself have taken the time to test or have a look at, no, they don't work. But it's not always sinister. Often they just don't know how to read instruments. Okay,
that's actually more depressing to me. Mark, that's kind of depressing. The idea that people spend a lot of time and money on something and they can't read instruments.
It's true. These guys in South Africa spent 300,000. I have seen multi-million-dollar efforts made where they didn't know how to read the instruments. And sadly, there was one guy I saw last year, 27 years of his life. He put into this and I said, by the way, you're using the wrong meter. When I showed him what was happening and he understood what was happening, his reaction was to grab a big bit of metal, and I think he wanted to bash me to death, so I had to get out of the building quickly. But they'll react differently. But it is depressing. And I tell you, when you forked out all this money for travel, sometimes I'm sponsored, sometimes it's investors. Other ones I can think of. Where I get angry is there's one company in Australia, they took $1.5 million of mums and dads' money by saying they had a magnetic motor. It didn't work. I told everybody it didn't work. They found it didn't work and went to court and found it didn't work, but everybody still hates me, even though I tried to warn them. So I can't win. And there are many, many, and it all gets down to one thing. Will they allow the technology like Yildiz? He always backs out at the last minute. Will they allow the technology to be third-party tested? Will they allow it to be, have a proper methodology used? And finally, the big question, can you close loop it? If you can't close loop it, you ain't got nothing. As simple as that. There's no useful energy. That's depressing. I agree. The exciting stuff, though, is what I told you before. There's an energy revolution happening. It's booming, and it's getting better all the time.
You mentioned a minute ago the HHO, and you did a lot of work on that. And I looked at your report or the page on your website and was quite impressed. I think our listeners might want to hear a bit about your findings with HHO.
Well, firstly, there's a lot of stuff I couldn't publish because people paid a lot of money and I'm under NDA, but I gave some general things. What we found with HHO that was very, very consistent, and I was dealing with diesel, okay? You do get a slightly better effect with gasoline or petrol-driven engines, but we wanted to get in the lab and test everything in real labs with real engines where we have real control, like the NREL lab facility we used. They had a supercomputer, in my opinion, or a big computer that was the engine's ECM management. So we could, we weren't fighting against the ECM. We could actually keep all the things we needed to the same. The trouble we had with on-road tests was what I call the, how can I call it? Well, we used to run these road tests in Texas many years ago. And if we told them we had the device on, that'd get us 15, 20% improve. If we told them it was off and it was on, it'd come back pretty much the same. So people don't realise they psychologically want something to work. If they invest in it, they get better mileage. But here's the breakdown in HHO very quickly. If you've got an old crappy engine that's got a lot of carbon in, it will improve the performance. It will clean that engine out very nicely. I've seen 10, 20% gains through fixing up old engines. It will get rid of carbon monoxide, nearly 100%, 90%, because carbon monoxide is a fuel. HHO is a fuel enhancer or combustion enhancer. So it will get rid of that. It will also get rid of a large portion of hydrocarbons, and that's all the unburnt fuel, basically. It will reduce particulate matter because you've got a cleaner burn. So it will do all those emissions things. It will not reduce NOx. Sometimes it does on gasoline engines, but on diesels, it's a bit of both ways. It will reduce EGTs, or exhaust gas temperature, especially if there's a bit of moisture in the actual gas itself. It's a bit like water injection. Now, as far as mileage goes, now here's where I really make good use of lab time. You walk in the lab and they're not allowed to tell you other people's results, but you sit down with the operators, the desk operators and that, and say, all right, how many HHO devices you tested over the years? And one of them said 15. I said, what was the best result you got in the engine lab on mileage? And they said 5%. That's the best, and that's equivalent to what we got, typically 2, maybe 5. However, on the road, you will get a better result. And here's the reason being. You do get a bit more extra horsepower. You do get, 10%, I'll say, extra horsepower. Now, if you're a truck driver or you're driving a vehicle, you're climbing up a mountain, you can use a taller gear. You can actually, because of that extra horsepower, you're burning the fuel that's normally going out the exhaust. You're not introducing another fuel source. You're actually, a little bit, but you're actually burning the carbon monoxide, you're burning the HC or the hydrocarbons that are unburned. So your mileage gain is firstly 2, 3, 5%, maybe 10% that you're burning that wasn't normally burnt and going out the exhaust. And secondly, if you're getting that extra power, you can use a taller gear. So you're actually getting more power using less fuel, and that can translate 10, maybe 15% mileage gains. If you're in a country with really lousy fuel, like Africa, some parts of Africa, you might see, I've seen results where we get 20% gains, but if you piss in the tank, you probably get the same result. You do anything to the fuel there, it improves. So that's what we found. And we also found a sweet spot, which was really interesting. There is a certain amount, if you're self-generating the HHO, there is a certain point, a certain spot where if you put any more gas in, your economy and mileage drops. There is a sweet spot. And we were able to predict that very, very accurately. Even before the tests, we were able to say, we think the sweet spot is there. So we'd run tests either side of so many litres per minute of gas going into that engine under a certain load. And it worked very, very well. So I don't know if I'm making you depressed, but HHO has a role. It does improve fuel economy, it does reduce emissions, but you'll never get a self-running genset out of it.
Well, I think I listened to you on the Smart Scarecrow show once, and you said there were some utilities taking, I don't know if it was diesel, but they were getting better energy production essentially by adding water. Am I remembering correctly?
Yes, great technology. In fact, that's been around for a while. Lubrizol did a fuel which was 15% water, 85% diesel, reduces NOx, helps with the power. We found water injection. This is one of the things we found with our testing. Water injection gives you a very similar result to HHO often, as far as cleaning engines up, and in fuel economy in some cases. If you do a combination, yeah, it's not a bad thing. Alcohol injection mixed with water. Man, if you want to turn your little pickup truck or your little, I don't know what you have over there, we used to get the technicians in Australia that we actually had a dyno rather than an engine lab. We actually had a dyno with a big truck on. The technicians actually said something like, holy shit, and jumped backwards when they saw the horsepower we're getting. You can increase your horsepower by 20-30% just by injecting water and air into the intake manifold. Alcohol and water. Huge increase in power. So if you want a rocket ship, just go and get yourself a snow, water, alcohol injection system. Man, that thing just blew everybody out of the water. It gives you better fuel economy, but the actual alcohol you use extra accounts for the fuel economy. So you use less diesel, but you're using a bit of alcohol to replace it. So, sorry, what was your question again? I got myself in a tango.
The issue is kind
water.
of
the water emulsion. Yes, it works very well.
Is that now spreading? I mean, are utilities around the world looking into this and they're going to start doing it, or what?
Well, it hasn't spread as quickly as it should, and I think that's more not because the technology doesn't work, but the company that's distributing it, they're looking into it. I looked at a big, massive steel mill, and they had burners, so we weren't using it in a combustion engine, but I have seen good results in combustion engine, but they were using it with the burners. And look, I've never seen the engineers at this steel mill were sitting there, and they're the proudest people I've ever seen. They've got all the data, all their methodologies were brilliant. They were proud. They're getting like 20-30% energy savings just by mixing the water with the diesel. But it wasn't just mixed in. There's a little bit of emulsifier needed, and they're using cavitation process to do it. So it's sort of stuck together. You know, you mix oil and water and it separates pretty quickly. That technology hasn't caught on fire around the world, pun intended, but I think it will pick up some game. But the thing that got me this week, that got me the most excited, I think it's the story of the year at this stage, for a whole lot of reasons, is the electronic control of combustion. There's a story came out this week, which out of left field, I just went, holy crap, and it's getting all these benefits that we've been talking about with HHO, adding additives, injection, and it's all to do with controlling the combustion process. We're not talking about combustion in engines at this stage. We're just talking about, you said, furnaces, fuel, burning, and it's actually using electrodes and putting an ionic field and using a computer to change with a flame to actually control fire with electronics. It's like being able to interface your computer to the flame in the combustion process. It's absolutely outstanding technology. And I'm thinking, wow, we started off with mankind with fire, and now we've actually come to the 20th century and they combine electronics with fire. We've got electronic control over fire. It's called clear signs electrodynamic combustion control. And these guys are serious. I mean, they've got millions of dollars behind them. They're only small scale at this stage. But what their impact on emissions out of coal-fired power stations and all that will be is massive. They're going to get a complete burn, and they could get up to 20-30% energy savings by introducing this technology wherever you're using a boiler or generating power, you know, burning a fuel or heating something with a fuel. This is massive breakthrough. This was really, really exciting. And I suggest you go and look at that story, because that to me was the most exciting thing I'd seen all year, possibly all decade, was his man controlling the combustion process with electronic control, and they're only using 1/10 of 1% of the energy. You know, HHO, you chew up 3 or 4% of the energy you have to gain back before you even get ahead. So this is a real breakthrough technology, controlling combustion with a electric fuel.
Where do you see that being used? I mean, will this be used in huge factories like?
Everywhere, everywhere. It'll be used anywhere where there's a flame, from your little stove at the restaurant right through to coal-fired power stations or gas-fired power stations. Anywhere where there's a boiler, anywhere there's a flame that needs heat. It's massive. Even the ships that still burn oil, and it's going to have a big impact. And where it's going to have the biggest impact is where the American government is doing a good job. They're legislating the emissions control, like on coal-fired power stations. Another reason they're shutting down. It costs these companies so much money to convert their power plants to be able to comply with the emissions law. With this technology, they'll be able to comply overnight without hardly any effort. The good news for the environment, we won't be getting the NOx out there. We won't be getting a whole lot of the bad nasties out there. Still want to shut down the coal-fired power station because of the CO2, but everything else is going to be improved. And the efficiencies can be improved up to 30%. So if we retrofit this to everything, it's a Band-Aid solution. While we're waiting for the other technologies to come through and be implemented, this will help a great deal. So to me, how it can be applied to combustion engines, I don't know. We've got to investigate that. But at this stage, it's going to have a huge impact on everywhere there's a flame used. So that's cool.
Yeah, that sounds most interesting. Hey, before we get too far away from the batteries and all that, what about the Hutchison stuff, John Hutchison stuff? You got any comments on that? The 0-point battery or any of the stuff that?
There could be something in his crystal cells, because some people have developed that technology. And I've seen some very interesting research on material technology generating power. But most of the other stuff is just, you know, he got backed pretty heavily by a company and other scientists, but the data never supported what he was claiming. And I like guys like that. They're pushing the boundaries in centric, but most of what he says is pretty delusional. It gets down to this. Okay, show me the data, show me how we can apply it. There's a lot of rhetoric, there's a lot of other stuff mixed in, politics, and we can do this and we do that, but there isn't the solid evidence supporting it, okay? That's my issue with him. As far as encouraging him, I think we should have a big pool of money like we give out to poets and artists and other people that can be creative but don't necessarily have to come up with something practical. You know, I think we should have a pool of money to support people like him, because it's more of an art form than a real science. And, you know, the good thing with these people, and I have to say this, they often come up with something that they don't realise they've got that triggers somebody else who knows what they've got to go down and develop something that's worthwhile. I see this all the time. And quite often I'm getting a story from somebody, I'm working with a team now, and I went, oh, that's pretty cool. We can use that as a neutron trigger. And a neutron trigger can be used for this and that. They don't even see that. They don't even realise what they've got. So quite often people like John Hutchison, their value isn't what he's actually produced, because he's produced something of no practical value, but what he has got is often very interesting and will trigger a line of inquiry that will be useful for somebody else that may develop something useful. So my view of people like John Hutchinson, we should have a big pool of money, we give them money, keep them going, but don't take out what they're doing too seriously. And I know you're going to hate me saying that, but that's the truth. You have to get down to what I've done. The truth is paramount, no matter what. You have to get to the truth. Without the truth, without knowing what's really going on, you can't progress. If you're basing everything on a lie or a false premise or a false assumption, you just keep chasing your tail for the next 20 years. Like that's why nobody could reproduce Stan Myers. That's why nobody can get anywhere with Bidindi devices. And the list is very extensive. But occasionally there is some little gem of information comes out that, be honest with you, well, the reason we're building this new battery technology using the water metals was somebody rolled up with a very simple battery, and it was a washer with a bit of copper, sat in front of a team of scientists, engineers, and I think we're going, huh? It's 1 milliwatt of power. I said, everybody said, this is bullshit. I said, no, it isn't. It's an inspiration. And they said, why? I said, wrong technology. Let's go find out what's there. And we found out something that would do the job. And suddenly the markets are there. The one we designed yesterday, the last weeks, those yellow flashing lights for roadworks, they have to put those lantern batteries in. It's a real pain to replace the batteries, and they go flat and all this. We're going to have one. They can leave it for 20 years and it'll run for 12 months without stopping, and it'll cost them less than 10% of the cost of running the existing ones, and no environmental issues. It goes back to an environmentally friendly material that is actually useful for the soil, rather than having a battery you have to dump in the landfill. So often what I'm saying is with John Hutchinson, what they come up with inspires other people, and that's their true value.
Yeah.
Oh, I'm with you on that, Mark. I've spent many a year in materials science R&D kind of stuff, and to me there's like practical R&D where you're really trying to get something done within a few years, and then there's more just like speculative investigation of phenomena, and in a sense it's obvious that he's working on something where we can't even describe it properly. So you talk of your famous motto about show me the data. Well, I mean, in a sense, he can't, because we don't even know, in a sense, what he's trying to do.
Well, I'm going to back your argument there and shoot myself in the foot, because you are correct. There's a gentleman at the first GBM, and he had a device, and it was a passive antenna. It was it looked like a couple of little beam antennas and another one, and it was a passive device. It was a few bits of copper tubing, if you like, arranged as receiving antenna and pointing antenna, and then put in a bit of a cover like a ball. And I'm sitting there, what the WTF? I won't say the swear words, but I'm there, okay, but I'm happy. But he was able to produce the data of what it actually did. And what it did was, this device, was it reduced, if it was put in a room, it stopped the salt dam, the moisture going up the brick walls, which may not be a big problem in your area in America, but in Europe it's huge. It's destroying historic buildings where the water comes out of the soil and travels up and corrodes, if you like, or erodes the mortar and all the rest. Big problem, salt dam, rising dam. And here's the thing, the methods they used to measure the effect, like what it actually did to the walls, was very scientific. You know, they had moisture probes and they had it all done very well. And he did parliament houses, he did monasteries. And here's the cool bit, they sold $500 million worth of these devices. But we could see the result, how it works. I haven't got a clue. I'm sitting there with Moray King, actually. We're sitting down, and I said, Moray, you've got to have a look at this. Because I looked at the guy's presentation, I don't believe his theories, but there is a passive antenna. If it's put in that room, it stops the water rising up the walls. But there's nothing we can measure. We can't measure any RF. We can't measure any known thing that we'd normally measure to produce the data of what the energy is going in, what's coming out, how the device is doing it. We can't measure. It's totally unmeasurable, but we can measure the result. So there, I say, this is real. We haven't got a clue what's going on, There's wacky things going on here, but we can see the result and measure the result. The trouble with John Hutchinson is he's probably at the first stage. We can't measure anything he's doing, but sadly we can't measure the result. With this other guy, we could, if that makes sense.
Oh, sure, because some of what Hutchinson's coming up with is kind of like fusing of materials in an uncontrolled way, or who knows what's going on. It's
Exactly right, and that's where he's got value.
It's very speculative and really probably, hate to say, but it may be for future generations, not for us so much.
I agree, and that's why he needs to be supported. Like I said, he should get an arts grant, because it's not going to have a direct benefit now, but it may inspire or come up with something for future generation. But you mentioned 0 point energy, okay? Here's 0 point energy, the problem you've got with. One is the density. They say half the universe is made of 0 point energy or whatever. Yeah, blah, blah, blah. But it's 0 point energy. It's the lowest energy state the universe that can exist. So it's not very dense. And here's the other thing, is like gravity. If I want to utilize gravity, right, 0 point energy is a bit like gravity. Here's the floor, here's the table. I raise a ball up, a lead ball. When I raise it up and I'm expending energy raising it, I've got potential energy there. And if I let go of the ball, it falls back to the earth and I can harness that energy. But I had to do the work in the first place to create the potential. 0 point's the same. It's right at the bottom of the list. It's right at the bottom of that table. To extract it, you have to put in equivalent or more work to actually extract it. The other problem I found was, and this is through a lot of experiments we did with physicists and in vacuum chambers and word escapes me. Anyway, we found, and there's another little experimenter I'd come across. In fact, he's quite a brilliant man. And he said, hey, Mark, I got this device and it's extracting energy from the environment somehow. I won't go into the details how. I said, okay. But he said, here's the interesting thing. If I have it here, I can get this result. And he had a tangible result, a measurable result. But if I put two devices within close proximity of each other, like within 10 feet of each other, they both drop, they're shared. And I said, what's the point? He says, I can put 50 of them in this same space. We're standing in this room, but I can't extract more energy than what's available with the interface I've got. So the limiting thing for tapping into 0 point energy, the ether or anything, is A, the efficiency of the interface itself in whatever form that is. You can compare it to solar. If I got a 20% efficient cell, I can get 20% of the incoming solar radiation converted electricity if I've got a 40% cell. So that's one limiting thing with tapping into the ether or the ZPE. The other thing is the energy density. It's a bit like, have I got compressed bottle gas in a bottle, or is that gas dispersed over, thousands of cubic meters, and if I light a match, it's not going to blow up. So they're the two big challenges for the people working with free energy or ZPE, is what is the interface, what is the efficiency of the interface, and what is the energy density. Like heat, we're around 10%. I'm reading this week we convert 10% to using solid state to electricity. Some company thinks they've got 50% now. With steam turbines, we can get up to around 38, 40%. So it all gets back to that conversion and the efficiency thing. So that's the challenge. And when you talk about magnetic motors or any other exotic technology, you've always gets down to this, the energy cycle. Please explain to me what the cycle is. Where does the energy come from? What happens to it? Or what form it's in? What it gets converted to? And how do we measure it afterwards? It's that simple. It's really that simple. So I don't know if that's going to help or hinder anybody, but it all breaks down to those very simple principles.
I wanted to ask you here about the small scale you know, whether you got a controlled flame or you're just a guy with a lot of firewood and a rocket stove and you want to convert some of that boiling water to electricity, what is there out there for, you know, the steam engine technology that's on a small scale?
I've seen some very interesting turbine designs in the last couple of years. This It's
I'd like
not
to hear
really an
about it.
area. Yeah, actually, I might write an article about it because there's one I come across in California. He had a very clever little turbine. But I want to straight off say two things. One, the efficiency never ever is above 50%, but there are some very simple, nice designs. One, I come across a guy in California. He had a very simple turbine design where everything was balanced. So rather than having a jet directly going to a blade, he actually had a disc or ring around the spinning turbines, and he had many, many blades, but he had holes in that disc. So it was an equalization of pressure at an angle. So rather than having 4 or 5 jets going in, you had a ring of jets. So you had perhaps 2 or 3 feeding before the ring, but the ring that was encasing or circulating, it was a floating ring too, the turbine, sort of broke it up into 50 different jets. I thought that was very clever, very simple. Little Tesla turbines. So there's a turbine where you can just convert, you know, steam or an expanded gas and closed loop and recondense it. There's a few of those. I should run an article. There's probably half a dozen. If you go searching the net, you find them. The other one that was very interesting, and this is where even universities get their calculations wrong. A lot of people were thinking, if we do like a refrigerator or compressor, we get that COP of 3.4, the expansion, the gas or the phase change, like air conditioning. People say they're over unity devices. There is an anomaly in the phase change of a gas that will show, they call it a COP of 3.4. And I found this company in Florida and I said, they got the university scientists excited and blah, blah, blah. And I said, yeah, here's the problem. You're theoretically using thermal units and all the rest, and you're getting this COP of 3 or 4, like your air conditioning fridge technically has. But if you ever try and convert it to mechanical energy, which you need to extract, you know, to generate electricity, you got to divide by that. And they couldn't figure that one out. I said, you go and do the test, and they did. And that's exactly what they found. They found their 50% plus suddenly become 10 or 15%. The other area to look at, and there's an article I'm about to do a story on this weekend, where some companies claiming they're up to, with solid state conversion of heat, the TEGs and the other, I'm trying to think of the name, there's a whole Peltier effect. They're claiming, they're typically around 10%, they're claiming 50%. So that, to me, if they have got that, that's a major breakthrough, because then you'll be able to, you know, hook it up to your boiler or your stove or anything else and get a 50% conversion. So I think there'll be some breakthroughs in that. The final area that I'm looking at personally, my research next year when I get all this stuff done, I'm working with one company on battery technology, I'm working on this lighting and radios powered, you know, no more batteries technology. Once I clear the deck with that, we got 3 areas that I find fascinating. One is, you worked in materials technology. The scientists I work with in Utah, they did some very exciting work in that area. It was only low power outputs, but they were able to create materials that could continue to generate electricity. They didn't excite me, but they had another one that really did excite me. And all the scientists looked at it and said, well, this should work. It doesn't break any laws of thermodynamics. It's sort of like using the nuclear properties of the material. That material could be as common as a zinc. It's really cool technology. I can't talk about that one, but it's so simple. We want to experiment with that. The other one I was very excited about was, you heard of thermocouples. Thermocouples, we managed to build one more accidentally than anything else, where we could have a thermocouple deposited onto a disc of silicon, that ran at room temperature. You didn't need a thermocouple needs, normally you need a hot and a cold, and the greater the hot and cold or the delta, the more efficient it is, the Peltier effect, okay?
Right.
We're able to do one same room temperature, and in Germany they've been able to do it, and in Japan they've been able to do it. And Hutchinson, actually, funny enough, he doesn't realise it, he's actually done it in the past, but he's never thought about it as a thermal reaction. So that's
thermocouples actually produce voltage based on temperature, right?
Yeah, well, we got one that works at the same temperature. So if you put it in a room, you don't need a hot and cold. It will work at whatever the temperature is. To work at the ambient temperature, we don't need a differential.
Wow.
So go figure that one out. It's to do with the material science. Well, that one, to give without giving too much away, different materials react to heat at different rates, right? If I've got copper, if I've got your hand and you're grabbing a copper pipe, and then I've got a silicon rod there, and at the top you're heating up both with a flame, the copper rod, you're going to let go of it real quick. The silicon, you'll probably be there for 3 weeks, okay? So the materials are reacting at a different rate to that environment, okay? Now, even in our environment, even though you think it's 37 degrees Celsius or 80 degrees Fahrenheit in your room, there's actually temperature fluctuations going on at a very minuscule level all the time. And if you've got two materials that have a different temperature differential, okay, they've got a different temperature differential at the rate they react to those temperature fluctuations, you're creating your own differential. One's always going to be a slightly different temperature to the other. So if you miniaturize that down, put an ionic conductor between them, and you do thousands of these, and you couple them up, series parallel, you're going to get quite a bit of energy. Does that make sense?
Well, in a place like the Philippines, maybe just the difference between being in the shade and being in the sun.
This will work in a box under your bed. It doesn't need, it can be inside a house. It can work at 50 degrees. It can be at that. You are correct with the other one. The typical Peltier effect, they have a hot and cold, cooler, sun, shade. So that's one that really excites me. And
when can I buy your flashlight, by the way?
I expect you'll see me in Walmart. Probably it's taken a lot longer than I thought, because what I thought turned out to be a little home project.
Oh God, don't make me go to Walmart.
No, I won't actually. You can buy them online, or you can buy them there. Walmart will probably have them though, but there'll be a lot of distributors. What turned out to be little backyard projects turned into a big project with manufacturers, with distributors and greedy capitalists and all the rest. We should have been in production 6 months ago, to tell you the truth. We'll be in production early next year. The business deal took more time than everything else, because when you're dealing with small amounts of money, people don't care much. When it suddenly turns into tens of millions of dollars, people start delaying the processes, and lawyers and all that get involved. So there's a lot of delays in the business process, but it is going ahead, and I'm very excited about it. And when you see the drawings we've got and the concepts, we've got 8 products ready to go. It'll just blow you away. My favourite's the radio. I sit here listening to my radio, and it'll run for 2 or 3 years without having to change the battery. I think that's cool. I love it. And, I went to the Consumer Electronics Show last year, and I'm looking at these hand-cranked emergency radios. When your country collapses and you're all in your bunkers and doing what you're doing in America, you got to crank this bloody radio every 10 minutes. And I said to the guy, what else? He says, we can do solar power. I said, that's good if you're in a bunker, but they can do solar power, but you need a panel. They said, what can you do? I said, well, see this, and I had a drawing there. I can power that thing for 1,000 hours. What? And it cost 20 cents. It blew them away. So the applications we got for this technology is just going to be so wide-ranging. Like I said, we're doing roadside blinking lights. We've got a lot of applications. My passion is the third world. I want to get rid of these kerosene lights. The injuries in India alone is over 1 million people a year injured by burns and flames. the tuberculosis rate is tenfold in a hut. And these people, they're the slaves of the oil companies. Up to 30% of their income goes to buying fuel for their lighting. If we can cut that down, suddenly they've got income to spend on books and education and luxuries like food. So my passion is to use technologies to fix up the third world and get a benefit in the third world. If you like, the first world will pay for it and subsidise what we do in the third world. That's what we're actually up to. So next year...
Well, Mark, it's good karma. Mark, it's good karma because once the U.S. becomes third world in a few years, then... Just
the only thing that's growing faster than the rate of your middle class falling off to the lower class is the rate of the growth of the middle class of the Chinese. That's the truth.
Yes, I know. Believe me, I know. So you have a range of these things, not just a flashlight. You've got several things that you're trying to bring out soon. Is there any on your website or YouTube or anyway, or are there...
There will be...
anything we can see. It doesn't even have to be working, just sketches.
I tell you what, it's a pain in the butt. Because of the business interests, the IP that's been applied for, everything else, it's all way under the radar. But it will be... We'll probably even do some Kickstarters of some of the products to get awareness. Not for the money, to get awareness. But... yeah, people will see it. It will come with a big bang, I tell you. There'll be 3 or 4 products released straight away, about 8 products doing different functions during the course of next year. And then we'll get other companies who come up with applications we haven't thought about it. There's a lot of applications like running EPIRBs and there's military, it's just endless. But we're doing that. I'm doing that because I want to do something that why we're waiting, and I keep saying this to these conferences and free energy people, why you're waiting for the preconceived 5 kilowatt black box that you want to power your house or your car, why we're waiting, and we could be waiting decades, John Hutchinson stuff and many others might be another generation. I want to do something now. I want my daughter's, how can I put her commandment, my daughter's wish, I want to leave a legacy for my generation, my children and their children, that I've done something that is actually happening now. And I have this argument with the free energy people. I say, why aren't you embracing solar? You know, solar's going to be 30 cents a watt. In fact, the inverters are coming down half price next year. You're going to be able to totally power your house for under $5,000 or maybe $2,000. And then you can plug your electric car in. Why aren't you embracing this? Why do you hate wind? Some have actually hated it. And I said to the conference guys, imagine somebody did come up with a over unity device. You'd all be out of a job because all you do is speculate and talk about it. Okay? Here's a list of people actually doing something. And stop rehashing the same idea over and over again. The people I love the most are the Russ Greases and the Zero Fossil Fuels and about a dozen others like them who actually get down, they run experiments. They haven't got over unity yet, but they're actually going through the whole backlog of over unity claims, working through them and saying, that one's real, that one's not. Well, I should better rephrase that. That one's got potential. Let's go and do more investigation. But that one, dead. So there are a lot of people doing a lot of good work. The other thing I'm pushing for at the moment is to get some standards and education and resources for people, so people don't spend 20 years of their life thinking they've discovered something only to find they've been measuring it wrong. So we want to get education information out to people. Anyway, I'm far from a good person. I think I piss off more people than I please, but the truth, there is no compromise. And that's where I stand and will always continue to stand.
Well, I guess that brings up the whole topic of what we in the West, or what, I mean, for that matter, listeners might be living in the Philippines, but what we can do, those of us who can afford solar or whatever, and how we might start looking into it or going about it. I mean, obviously some people are more technical than others, and you know, some people have more money, but have you got any suggestions on that front?
Oh, yes, and this is... I
can't buy your flashlight, so I'm kind of stuck.
No,
I'm not, and if I go in Walmart, I kind of, you know, I don't know. There's something, I don't have enough garlic, and I don't know, something to protect oneself. But
Yeah, well,
what can we do?
Walmart, well, here's where I'm saying to the global breakthrough energy movement and all these people saying, why aren't you evangelists on this? In America right now, if you want to, depending on the state, you can go in and they will put at no money down a solar system on your house. Okay? Won't quite cover all the energy needs, but they will put a solar system, maybe 4 kilowatt, whatever, on your house. Everything. Hook it all up, no money down. You'll pay that off. One scheme I looked at over 7 years. The savings you'll make on electricity during that period will more than cover that lease payment. At the end of the 7 years, you own it. You got your own power station. So people can do it money down. And a lot of other companies worldwide are coming up with very, very good schemes where you can actually get your roof covered with solar. You still pay for the energy, but no money down. But you're doing something good for the environment straight away. If you want your own power station, don't want money down, you have to do it a lease buyback scheme. But the cost, if you look around, now there's a group where I really, really love, and you asking me what I'd be doing. I ran this story on this group recently, and what they do is they act as a community. So they're getting war veterans, they're getting people in tech colleges, electricians and all that together, and they're allowing them to train by installing this stuff on their houses. And everybody else is a volunteer, whether they're making the lunches or they're contributing or doing the paperwork. They're an accountant, so they're doing all the form processing. And they're coming together as community groups and they're putting the solar on their houses. And all it's costing them is basically, and plus they're bulk buying. They're absolutely bulk buying all the materials. So rather than going to Walmart and having to pay $2 a watt for your panel, they're buying between all of them a container load, and they're buying it for 70 cents. My mate in America buys them for 60 cents a watt for A-class panels. So they're getting together as a community and they're installing these solar panels. They're training war veterans and all these other people in the skills and technical side, and it's costing them the materials and their time, a bit of volunteer time, plus a little bit of money to pay for the professionals that have to be there to accredit to them and train them up. And it works out, the cost of installation is a fraction, because I don't know why in America, but in most countries now like Australia, I can build a solar farm for under $2 a watt. I can get it installed on my house for $3 a watt. In America, it still costs you $6 a watt, $5 a watt. Okay, the actual solar components and everything are soon going to be under $1 a watt, but it's going to cost you $4 a watt for the labour and for all the bureaucracy and all the rest. Why not get together a team of people, like-minded, the templates there, the expertise to help you organise that's there, and go and get all, get a dozen, get 50, get 100 people together, and do your own systems, and you'll get solar on your roof for say $1.50 a watt. That's what I'd be doing, forming these cooperatives and communities, and the group that's actually doing that at the moment, I can find their website for them. That's what I'd be doing, or I'd be purchasing. I keep saying, what, if I rolled up the GBM conference in Boulder this year, I would have walked in the room, because I can be a real asshole when I want to, and I say, who cares for the environment in this room? And bang, up goes 100% of the hands. Okay, who's got solar on their house, or some sort of windmill, or some sort of environmental technology assisting the environment? And I bet you less than 10% of the people would have put their hand up. And I would then said, why? And then I would have spent an hour having the audience tell me why they haven't done it, and analyse what their insecurities are, what their knowledge base is, and why they've taken the decision to date not to do anything about it. What's
it's
their
all
excuse?
about taking personal responsibility.
Well, why don't people do that? I want to tell you something briefly about a culture in the Philippines that really excites me. They have nothing. I'm living in an area where people don't have anything, but they have extended families. That's their social security. They have humanity. They have, everybody helps each other. They have humour. They're in the top 5%, always, the top 5 countries, not 5%, the top 5 countries in the surveys, the happiest people in the world, okay? Here's the thing that's blown me away here. In America, we're all guys here talking. We're all doing the tech talk. We're talking solar energy, cars and all that, technical and that. Okay? Typical in Australia too. Here, I was at a function the other day. The men are sitting there drinking, playing cards. The women are all sitting down talking about solar, fuel efficiency, turning plastic to fuel, comparing their latest e-motorcycle they just bought, charging rates. The women are sitting around in this group excited about energy, renewable energy, and what they're doing and their individual efforts of saving.
Seriously? In the
Yeah,
Philippines?
I'm sitting here and I'm sort of like, well, I should be drinking and playing cards with the men, but the women have got me dragged aside. Come on, Mark, tell us about what's involved in this. Can I do a gas digester? This is a group of women. And I'm going, oh my God. It's sort of like, we're not talking about Cameron Diaz's, latest face job or boob job and all that, or what happened on Miley Cyrus's latest video. They're actually sitting there. And you know what's driving this? The women is the economic drivers. They've got very little resources, as in money, so they've got to make things stretch as much as they can. So I'm in a house now, and I've got to tell you, we're paying about the same as the US for electricity, which is about half the price of Australia. I've got these light bulbs everywhere here that are energy efficient. They've got an energy-saving device, which I haven't pulled apart yet to see how it works, but it bloody works. It sits on my fridge. I think it's tricking the meter. It's not free energy. It's tricking the meter. But these women, as all economic driver, they need to save money. They need to stretch their dollars. So they're looking at how they can recycle everything, how they can save energy, how they can better utilize energy. What resources have they got? So one of the projects I am going to work on next year is a very low-cost plastic. They've got a big plastic pollution problem here. A little really low-cost, few $100 plastic to fuel digester. So they can get all this scrap plastic they got and turn it into fuel, which they can then use to cook with or run their motorcycle. But these women are riding around on e-bicycles and e-motorcycles. They're seriously interested and, got me sitting there getting grilled about what they can do as individuals. And I was at a show recently where they had a lot of these people with the, small water turbines and all these other beautiful technologies, tidal power. And the women were there too with their husband. And they knew just as much as you talk to them. They know more about it than their husbands sometimes. So I'm just blown away that the women are involved. So I'm trying to figure a way, how can I get women more involved in this equation in America? Because the women often run the household budget. In Australia, my niece, she put the solar on the roof, not the husband. Then she realised, shit, I can make a lot of money here. So she put more panels on. She gets a check from the utility company. And she manages that. They do all their washing and that at night. During the day, they're selling their excess electricity at 3 times the rate. They're buying it back at night. The women are the drivers. So you've got to get the women involved, put an economic case, solar will happen, wind will happen, free energy will happen.
Mark, what was your wife, the website your wife posts to again?
It's linked to our Revolution Green. It's called Breakthrough Energy News. So okay. What she does every day, she scans all the press releases, all the science journals, and she comes up with stories which we still use as our stories. I'm looking at today, Samsung's digital village debuts in South Africa. Dutch wants to vacuum China's smog away. So the Dutch have come up a way of making the smog disappear in the cities. World's most powerful terahertz quantum cascade laser. This is my wife finding these stories and putting them up. I'm going, holy crap, I don't even know what that means. So Ken and myself, who post the stories, we often go to the Breakthrough Energy News site. She has a couple of people helping her. There's a guy up in Seattle, Pi Po, I'll call him, a physicist. He sends a lot of these stories, and he's painstakingly, she's learning about all this stuff, and then she's passing it on to their friends. So our fan base in the Philippines, who look at our site, are actually the women. This is freaking me amazing. Out. And I'm thinking, wow, here's a country, 90 million people. They're going to be 100% renewable for their grid, but they're looking at electric cars on a major scale, And the women are the ones, they're interested in, well, how do I convert plastic to fuel? How do I put a digester in my house? How do I turn this scrap? How do I run my stove more efficiently? They sit there talking about that here when women in the West are talking about fingernail polish, you know. So how do I change that?
Do those plastic to fuel converters, are they taking off and working pretty good then? I heard about them a year ago.
Brilliant. In fact, a lady in India has come up with a pretty cheap one, you know, village level. There's one here down in the Philippines. They have this mountain here called Smoky Mountain. And it is a mountain made of plastic refuge, and it's smoking. They don't know what to do with it. It covers acres. So this company set up alongside, and they're actually converting all that plastic into fuel. I'm not saying that's good for the environment, but it's a hell of a better use than letting the plastic smouldering away there for years. And they do work very well. What's needed is a very small, cheap, home brewed one, you know, one for $500 that you can buy complete, or you can buy the components, the controller for $200. It's a very, very simple process and not that hard to do. All it is you got to have the plastic. Tires work better. Tires give you more fuel. But to give you a conversion rate, if you got a kilo of plastic, you'll get 85 a working metric, sorry. But if you got a kilo, which is 1,000 grams, you'll get 850 grams of fuel. So it's an 85% conversion rate. And depending on
what kind of fuel? What are you talking about? Gas?
Well, you get two things. Gas as in, you know, fizzy stuff. You do get a bit of gas as a byproduct. With gasoline, diesel, kerosene, you can have whatever you want. It depends on the temperature you crack it at. And the temperatures are quite low.
Right.
So all they're doing is you're putting the plastic in an environment, okay, that has got a temperature set, is a very accurate temperature, in an oxygenless environment. So you either have a vacuum or you have an inert gas in there, and it can't burn. So what it does, it turns into a gas, if you like, and then they filter that, bubble that through some water, and you get the fuel forming at the top, and you get a little bit excess gas you can use there to help heat the process. It's a very simple thing. So I'm talking to some guys at the moment, I'm saying, if we can come up with a really cheap, you know, $50 electronic controller box, and the rest of it can be easily obtained. This isn't high tech. This is something that I'm not very high tech, but I could even do it. And I want to have a device that is a kit or a project or something that all these women I'm talking to, 10 of them might get together and buy one and put all the scrap plastic in and run their motorbikes on already e-bikes, or use it as a fuel at home. So I think there's a big need for that, but the technology is pretty easy to do. The trouble is the commercial units are available, geared up for big production. You've got to pay 10, 20 million bucks for one. What I want to see is the small home one. There's a scientist in India. She did one that's less than $1,000, but I think it could be taken a step further and you could end up with one at very low cost. So you can build one very easily. So I'm excited about stuff like that. I know it's not free energy, but it solves a problem. It solves a plastic pollution problem they got here.
Right.
And it gives these people, and these people then can go and, with the money they save, they will buy the solar panels. They will do that. They will pour the money back into becoming energy independent, because energy in third world countries can consume 30, 40% of your income, which is huge. Electricity bill here, even though it's cheap, is still up to 30% of their income, which is a massive amount of money. So if we can get it down to 10%, suddenly they can pour more money into becoming energy independent. And I think basically the free energy movement, why are they in it for? They want energy independence. And getting back to that minister from England, he's saying, we want you to have energy independence. Stuff the corporates. We want you to have it. The technology is there today. It's a matter of knowing how to go about it, to do it, and taking, as you said, individual responsibility. Many of the free energy movement people, they want the government or somebody to come with a magic wand and give it all to them. Never going to happen. Never going to happen. And then the free energy device, let's say the Rossi thing, or any of the devices, Bedindi, let's say they're real. What's it going to cost you to buy that device? But if my niece has already got 5 kilowatts of solar Her house is free. She's getting a check from the government. She's recharging her electric car. So her energy needs are all met. Okay? Why would she go and buy a device like that? I mean,
she wouldn't.
she wouldn't. And I'm
No.
telling these people, you're missing the point here. Who's going to buy it? And then it's got to compete. Solar, including everything now or next year, will be under $1 a watt. That's inverter, panel, fittings, wiring, everything. Not the install, the technology. A lot of these exotic technologies, they're talking $4 or $5 a watt capital cost. Can you see the problem there? It's going to be, will the free energy, so-called over unity technology, and what's going to be the running cost of a Rossi thing? What's the maintenance? What's the lifespan? What's the depreciation? What's the capital cost? You know, whatever it costs to manufacture something, it's 4x. That's what it costs in the market, or 3x. So if it costs $2 a watt, it's going to be 6. So is it actually going to compete with existing renewable energy technologies? So that's the big question they're all ignoring. And they're just saying, oh, it will save the world. It will cause a revolution. It will enable an upheaval. Well, actually, a lot of people like my niece is going to say, no, I'm okay. Who cares?
Yeah, she won't really care if the Federal Reserve note collapses and we're all using Bitcoin. I just had one other question, and I've got to get off here. It's been a story I've heard for 20 or 30 years, and I might not even be right, that it's in the Philippines. There's been a guy that been driving around putting water in his tank for decades. You're over there? I was just curious.
That was Daniel Dingo. He passed away. It was never ever 100%.
Okay.
Water. It was a supplementary. I think it did get some commercial production, but there are some good-hearted people and inventors here. There's one I talked to, and his heart's in the right place. His knowledge isn't. But there are some other ones here who are just crazy bastards who don't know how to measure things, but they're trying. And here's my dilemma. I don't want to discourage people. I actually encourage people. I help people. I've even financially supported people to move ahead with technologies and experimenting. I want to have them to have the resources. The only thing I've got a problem with is people claiming something that isn't true. That's all. The scam artists or the delusional who mistakenly are claiming it, because that can be very damaging for the whole industry. It's the old thing, crying wolf. I keep telling Sterling, you claimed for 6 years or 12 years, this is real, this is real, this is real, this is real, every day at one stage for 12 months, and none of them panned out. You know what happens? Your credibility goes out the door, okay? I have people who think I'm an arsehole, but the people with the bucks and the people that count think if Mark says it's real, they take notice, okay? I'm not always right. I'm sometimes wrong myself, but you've got to have credibility. You can't get credibility by claiming everything that's ever been done is real. You have to sort out what is real to move forward. If you have a foundation of truth and reality, then you can move forward. And the other exciting point, I know you've got to finish up, there is a revolution going on now. Get on board. Solar, wind, wave, thermoelectric. And soon as they have the battery or the storage technologies resolved at economic rate, which will happen, they're in the lab, they're coming across. Look where the big money's going. There is $100 billion a year being invested on energy research each year. $100 billion. In the automotive industry, $12 billion in the next 3 years is being invested in battery technology research. $12 billion. Kleiner Perkins and all these smart investors, all the dot-com boom guys and all that, they're investing in battery technology research. IBM, every company in the world's investing in storage solutions. And there's some 30 or 40 companies with very exciting solutions coming. That is going to take it from what we're seeing now, where there's a rapid uptake of solar and wind. It's still minor, but it's getting fast in electric car. It's going to go into hyperdrive. As soon as that technology is available, you are going to see a boom, a huge revolution. I will go down the street and buy my car that's got a 1,000-mile range on a single charge tomorrow. I will not buy one that's got a 90-mile range. Okay? Just don't want it. So you're going to see in the next 5 years hyper boom. If somebody comes up with a free energy technology, great. If they don't, well, we're still going to be okay, in my opinion.
Mark, one last question here, and that would be, for those of us who are kind of technically inclined, setting aside solar, what are other things you would suggest we play around with or consider, buying for our house or whatever, that kind of thing?
Well, I think where the developments are coming is storage, thermal, electric, some other and small, low-scale nuclear, like even down to the house level, you might have your nuclear reactor in your house. I think the other things I'd be looking at, and this is quite booming in Australia and Europe and Japan now, is people who've got access to cheap gas. They're getting these about the size of a dishwasher, a box, and it's converting gas into electricity and heat. And so they're boiling their water for their hot water, they're heating and cooling their house, and they're also generating electricity needs. They're co-generators. And so what they're doing in Japan, a lot of people who really are pissed at the moment with their power companies and the government, well, the government's putting in, consortiums are putting in these big, the wind farm that's replacing Fukushima will be a gigawatt. Okay, it's not a little wind farm, it's 1,000 megawatts, okay? But what they're doing is they're putting solar on their roof. They all love the solar, but for their heating requirements and their nighttime and their hot water, they're putting these gas generators because they've got access to cheap gas over there. And what they found in Australia and Europe, if you put one of these in and you've got gas piped in your house or using bottled gas even, they're actually generating electricity way cheaper than what you can purchase the power off the grid. So it's not free energy, but it is a solution where people can get a bit more independence and save some money. And you're going to see a lot of product coming out on the market in the next 2 or 3 years. Some big corporations have really cranked up they've already got product out there, but are cranking up the cost. The other thing is fuel cells. Fuel cells are going to come down in price dramatically. There's some out there now. The trouble with the fuel cells for vehicles at the moment, with a fuel cell you can run your vehicle on anything. It's an electric vehicle, you can run it on virtually gasoline, gas, hydrogen, whatever you like. It's the cost and the longevity of the fuel cells. The technology is here now that is going to drop in price dramatically. So apart from solar, I'd be looking at wind. I'd also be looking at geothermal. A lot of people using for heating and even electricity production now in America, they're putting in things into the ground. They're digging a hole in their backyard and they're tapping into the Earth's warmth, if you like, and creating thermal cooling. And yeah.
Well, I'm normally in Japan, and so I've looked into, for example, geothermal, and the companies, building houses that use it and so on. And I'd say
it's expensive.
It's awfully expensive. And even with solar, it's a tough call because the utilities here are so evil and expensive and getting more expensive. That it's an incentive, but still it's not the kind of numbers you maybe have been talking about in Australia with, serious government subsidies or whatever. So it has been a mixed bag here looking at that. It's
changing. The model is changing in America, but what you have to watch out for is the power utilities are waging a war against individuals owning solar in their houses. So if you still have to remain grid connected, until we get a good solution for energy storage, it makes good sense to stay grid connected. They've already got test cases in several states challenging, and they want to charge you more for the power you consume than the other people that don't have solar. So they're running an anti-solar campaign now. That's what we've got to watch out for. But the economic model is changing rapidly in the US, and there's a lot of companies coming up with some modelling that will appeal to you. I know what you're saying, it's borderline, but it's all about do with our commodity. In Australia, the subsidies are gone, basically. They've gone now, and it still is more economically viable to put solar in than connect to the grid in many areas.
Well, that's a positive thing. Well, I think that just about wraps it up. Any last thing? I mean, your website.
I haven't got a company website where my work is. The website that you see that I do is just a hobby for me. I do it with Ken, who's in Utah, and we've got a few other people who are involved, technical advisors. So it's very simple. It's revolution-green.com. And the other one, which is linked to that site, is Breakthrough Energy News, oneword.com. It's just Breakthrough Energy News. And all we're trying to do with this is, and what's already had a huge benefit, is to disseminate information, but more importantly, link up people. And what's happening more and more and more, and you see this in the background, you don't see it in the public forum, we've got a really good comment section. We don't censor. If you go to Free Energy News, 90% of the people I know are censored or banned or whatever. They're not allowed to say their piece. Here we don't do that. We don't allow personal abuse, but we don't allow that. And what we're finding is these networks are developing in the background where people are now contacting each other and co-working on projects. And this last week, there were 3 separate projects where this person in this country working on that has suddenly teamed up with another group that he didn't know existed. In fact, in Iceland, there was 2 of them said, we asked you to introduce us to people, and you introduced us to ourselves, and we didn't know we existed in our own country. It was really cool. But we're seeing these networks, and the whole idea of the site is to get those people in contact with each other. So suddenly it's gaining some momentum. That's some really cool stuff's happening, and people are able to exercise their opinion and bring levels of expertise together, come out of the closet behind the scenes and work with other people. So I think that's been a great success story that we weren't expecting or intending to do.
Okay, well, Mark, thank you so much for your time and for enlightening us. And I'm looking forward to that flashlight in Walmart and reading your website and then hearing your further adventures on places like the Smart Scarecrow Show and wherever else. So thanks again. We appreciate you coming. That's it for this week.